Hey Michael, hey Camille.
Hi Eddie, how are you?
Yeah, good, good. So you present today
Fine.
or Hamad will do it?
Yeah, Ahmed will do an introduction, then I will go through the high level design. So
Good.
I think, yeah.
You're based in the Rome, right?
Yes, we are in Rome.
Oh, okay. Yes, thanks. It's quite late for you.
It's quite late, right?
Yeah, it's hard to making it's global available. You already joined the Cisco, right? You after your graduate.
Yes, I graduated in April, I
Oh,
think,
okay.
yeah,
That's
few
good.
months ago, and then
Congratulations.
now I
Yeah.
joined the Cisco.
Okay, that's good. I heard it's not easy to get the offer in the Europe. Let's wait for a couple of more minutes. Does any of you come to the OCP in that week?
I'll be around, maybe.
Oh, that's good. Yeah. I saw Pavin also had a talk about the DSF in the workshop.
Yeah, that's right. So he's going to be also there.
Yeah, that's good.
Yeah.
Mhm. Oh, the DSF is on the Q200, right? Not on the G200. Oh, I saw Hamad here.
Hello. Hi, Eddie. Hi,
Hey,
everyone.
hi. You based in the San Jose, right?
No, I'm based in Europe, so it's
Oh, you're
quite,
also in Europe.
yes,
Yeah. All right.
it's it's Friday here.
Hmm. Yeah. I'm in China right now. It's also the Friday morning. Mm.
Okay.
Yeah.
So
They have yeah.
you guys are men of the future.
There is nothing is changing in the future, so I can tell you that Friday is almost the same as Thursday.
Yeah, thank you. Thank you. I'll feel much better tonight.
So don't worry about tomorrow.
It's the same day. Okay, I think we probably can start it. I think today we have like Ahmed and the company talk about the SRE6. They have one proposal on that. And the other one is like say before we started, I want to see that because we have the OCP coming in the week of the October 17th and the 19th for 3 days. So I'm wondering like what we do for the 19th, our weekly meeting. One is like say cancel it, or the other one is I can host a local face-to-face meeting on 20th in Alibaba office. So if you guys will want to come to the visit to the Alibaba office, I will happy to host the meeting there. So
I'll be
any
happy to
comment?
see it. Yeah, absolutely.
Okay, then maybe I will send out my email. Like I say, if you have like want to join for that meeting, then we probably have a chat there. So just let me know how many people and who under the name, so I can let our front desk people aware of it. Yeah, that's good. Yeah. So Ahmed, do you want to start?
Yes, thanks, Eddie, and thanks everyone. So it's gonna be quite actually a short presentation, and there is a bit of brainstorming that we would like to do with the team attending the meeting today. So basically, it's about, and Carmine will share his screen to present the high-level design that we have for this feature, and it's basically about the support of layer 3 adjacency in SONiC. And to give a bit of context, SRv6 has been supported already in SONiC, as you know, and there are the different types of seeds that has been added into the AppDP, and we have the orchestration agent that is basically supporting the programming of this into the ASIC-DB. One of the parameters that has been missing in the existing SRv6 code in SONiC is basically the programming of the layer 3 adjacency. So basically some types of seeds like the cross-connect ones, basically they are programmed with an adjacency. However, the orchestration agent of SONiC right now ignores completely this layer 3 adjacency. And basically the proposal today is to add support for this. We have few cases that we want to handle in this high-level design, basically to install a new seed, to delete an existing seed. But there is one that is open for brainstorming, which is when you have a seed programmed and the next hop of this seed gets deleted for some reason. What should be the way to handle this use case? And it's open for brainstorming. Should it be SONiC and the orchestration agent in SONiC to handle this case, or it should be FRR or whatever? So it's open for brainstorming. Carmine, please go ahead with the presentation.
Thanks, Ahmed. So, yeah, the goal of our proposal is extending SRv6 org to support the programming of layer 3 adjacency attribute, which is required for a set of SRv6 behavior. And SONiC already supports SRv6, it supports several behaviors. The application DB was already extended to support these behaviors, and it includes all attributes required by these behaviors, including layer 3 adjacency. Then we have a service 6 orc that receives seeds from application DB and install these seeds in ASIC DB. The problem is currently a service 6 orc has an issue. It processes all attributes except one, the layer 3 adjacency attribute, which is mandatory for some behaviors. And basically we are proposing a solution to fix this issue. We want to extend the service 6 orc to be able to process the missing layer 3 adjacency attribute and program it into ASIC DB. So let me show you an example. Here we create a seed in a service 6 myseed table of application DB. This seed has two attributes, the action, which is the behavior of the seed, and another parameter, which is the adjacency, which is an IP address. Then a service 6 orc receives a myseed table update notification from application DB because it is an application DB subscriber. And then a service 6 orc interacts with neighbor orc to discover the next hop ID of the adjacency. And finally, a service 6 orc installs the seed in ASIC DB. This seed object installed in ASIC DB has a next hop ID attribute, which is set to the next hop ID found previously. Okay, this is the high-level design diagram. So now, when install a seed, we have several possible scenarios. First, we need to consider if the next hop exists or not. If next hop exists, it's easy because we install the seed in ASIC DB and increase the next hop ref count. Instead, if next hop does not exist, we have two options. Option 1, we keep retrying until the next hop becomes available. Option 2, we listen for next hop change notification. And when the next hop is available, we install the seed in ASIC DB. So, do you have any comments on this scenario, on these two options?
Don't we have a case to create the next hub itself, or like you will? So who is creating the next hub in this case?
And also, can you explain a little bit, like, say, how the seed and next hop associate together? Especially when you listen in the next hop, so how do they link the next hop with your seed?
So I think let's take them one by one, Carmen. Maybe the first question is who programs the next hop? I think this is being programmed by FRR. The configuration of the next hops come from FRR already, no? Who programs the next hop in SONiC?
Okay,
Well,
so
this next hop is for us next hop, or this is the forwarding next hop? This is my seed, right?
No, so basically let's take it one by one, and the option that Carmen has here, there is also another option 3 when the seed does not exist. So basically when you install when you get a new SRv6 seed, so basically you can get it now, for example, from FRR, because ISIS has been merged. So you can, when you configure ISIS, you get your end.x seeds allocated, and you communicate this to FRR. So when you get the seed, you get basically the seed and the IP address of and the layer 3 adjacency. This layer 3, when you get the layer 3 adjacency, you need to look at, or you call there is a orchestration agent for the next hop in SONiC, where you call this agent and you check for what is the next hop associated with this layer 3 adjacency. And here there is a third option when the next hop does not exist. So if you get a seed and you get the seed and the next hop exists, it's easy, you program that. Then if you get a seed and the next hop does not exist, there are actually 3 options. The first option is to fail. And we can, these are still open questions. The first option is to fail because I have a seed with the next hop that does not exist. So should I wait until the next hop gets ready, or I should fail because the next hop is not there? So that's the first option, is to fail. The second option is basically I have the next hop, but it's not there yet in the next hop agent. So should I wait and keep retrying until it becomes available? And this option 1 and 2 are basically the same way, but one way is to retry, and the second way is to wait to get a notification directly from the next hop agent when this next hop becomes available, and you go and program it. So honestly, we don't know which option should be the best in the 3, either to fail or to wait until the next hop become available.
So when you say listen for next hop notification, so are you maintaining some kind of a pending list? Because of the next hop is not available, you are basically delaying your SID programming itself, right? So can't we maintain some kind of a pending list, and then once the next hop is available, you program the SID instead of listening for this notification and all those things? I don't understand what this is.
Carmen, you want to take this one, or you want me to add something?
Yes, there is a mechanism in neighbor org that basically a neighbor org notify other orchestration agent when the next hop changes. And so we can attach a handler to this notification. When we receive a notification for a next hop change, we handle this notification and we install the seed in SICDB.
Yeah, but this is within the ARC agent itself, right?
Yes.
So if it's within the ARC agent, you can go across ARC modules, and then you can do it, right? I mean, you don't need to listen for the event or all those things, right? When the next hop is available, you are going to walk through all the pending list. You see, okay, for this particular next hop there is a seed waiting for programming, then you can program the seed when the next hop is, as soon as the next hop is available.
Yes, that's the approach that Carmen actually was explaining. Is basically we get the seed, we wait until we get a notification, and once we get the notification, we go our through waiting list, and if this next hop relates to one of the pending seed, we program it.
Okay, so maybe this next hop notification is not a Redis notification, right? Redis PubSub. This is the internal notification that we're talking about, correct?
Yes.
It's from the Orca agent.
Yes.
Okay, got it.
But I have one question. Is like, say, why SID and next hop will be separate? Because you both learned from the ISS or OSPF, right? Would that be part of the next hop upgrade, the information?
I think, Eddie, they are separate because in SONiC they are, they are handled by 2 different agents. So the next hop is handled by the neighbor agent, and the seed is handled by the SRv6 orchestration agent. And in the case of the adjacency seeds, like index or etc., basically you have the 2 pieces of information, so you need to cross-check with the other agent.
Yeah, that's for the OC agent point of view, right? But my question is,
Yes.
like, say, from the FR point of view, you get one message or two messages. So to the FPM, so you will only get one message for the net hop, right? Or you are saying this net hop will going through the Linux. So we are talking about using net hop group that kind of approach, right? Which means that the FR will get net hop information, and the net hop basically itself will have the SRv6, whatever the state that you want for the IGP net hop, right? So then eventually you will be the one object in the FR.
I think there are two options to do two objects, but Carmen can correct me. So I think you have the next hop already installed in advance, and once you get a seed allocated, this seed will refer to an existing next hop. Correct, Carmen? So basically, the next hop might be actually programmed way in advance, and because it might be used by another route, for example. And basically, when you have a seed that point to this, so you're going to program the seed separately. So they are two different objects.
But this seed is basically you learn through the ISS, right? Which
Yes.
is your part of your more like say your MPR the NH, right? This is your SRv6 NH. The moment you're talking about SRv6 NH, then the set is basically it's a property for the NH, right?
Yes.
So you will not be able to share with the regular IP NH. You have to create your own NH on your own in the FR. Basically, say that whoever need using the SRv6 will point into that, not the regular SRv6 NH, regular v6 NH, right? So this is more like the label NH from the NPR's point of view, but this is SRv6. Is that correct?
I will let Donald and Carmen comment on the FRR part. I think they know much better than me. Carmen?
Yeah.
So the question is, when you get an index function or an adjacency seed in FRR, does it, how to say, point to an existing next hop, or it gets a new next hop, or it creates a new next hop? Is it your question? Did I get the question right, Edie?
Yes. Yes.
So in the ISIS code, when you enable ISIS on an interface and you allocate an adjacency seed for that interface, then do you create a new next hop, or you use an existing next hop?
No, it's an existing next hop.
Yeah, it makes no sense to create new ones, already an existing artifact.
So how come you could reusing the new next the existing, because the new one it's just like say for the normally the MPR's case you have the MPR's NH versus the IP NH, right? So if you have the label, you always do the MPR's NH because your encapsulation will be different. So if we using the same thing, then SRv6 should have its own NH, right? Because basically, you as part of NH, you should have your SRv6 context associate. So say, hey, this is the SRv6 the IGP label, so like equivalent to IGP label, which need to be inserted. So then, which means that you cannot share with your regular IP NH. You have to have your own NH, which has your context.
Is that right, Dodi? Like this is an adjacency SID, right? So there's
Yes.
there's no more encapsulation, right? This would be
this is
this would be
the one
popping our local and then forward, right?
Oh, this
Yes.
I thought this is the one you learn through the ISS, right? Then which means it's kind of like the IGP label, right?
No IGP label. It's a regular next hop, right? It doesn't matter whether it's coming from ISIS or BGP or whatever.
That's true.
Yeah.
Yeah, but what I mean is like it's kind of like equivalent to the IGP label. It basically say so. Then my question is like for this particular set, which is the corresponding object to associate with it. So you if you want sharing the NH with the IP, then somebody to hold on that information, right?
So in MPLS, you pop the adjacency seed before you send traffic, right? It's going out without adjacency seed, obviously.
No, but this is the remote learned, right? You will pop the adjacency seed at once you arrive the remote PE, right? But this is your learned.
Yeah, so service 6 is different. In MPLS, you have capability to signal whether a JCC has local or global significance. If it has local significance, it has to have nodal seed on top of it. You cannot expose labels that it's local.
But that doesn't matter, right? That means that for the whoever publishing those MPLS set, they will publish it as a regular IDP label, right? So just to say you have one label or two label case, right? But these two should still be from whoever receive it. This is just some kind of encapsulation for IDP label, right? It doesn't care it's the adjacency or not, right? For his action, you just say I want to impose those labels and send it out. So that's why we have a separate MPLS NH versus the IP NH, right? That's because the encapsulation anyway will be different. For this particular case, it's my logic IOC is kind of similar, right?
But because the thing here, you don't encapsulate AD. You get the packet, you do lookup, and you forward on a given interface. So it uses the same IP next hop.
Oh, you mean like this is the one you? I'm a little confused. You say this is learned from the ISIS, right? Or this is a local.
So basically, when the packet gets to this node, you're going to do the how to say the regular lookup, and basically then you're going to instead of forwarding based on IP routing or how to say LPM, you're going to forward on a specific interface. So this seed is basically bound you to a specific interface.
Okay.
Bound to IGP adjacency. It's not bound to interface, right? It's
yes, it's IGP. It's the adjacency. Yes.
So this is not learned. This is basically your local adjacent set, right?
Yes,
this is
on my node.
On my node. Okay. I thought you said this is learned through the ISIS.
No. When I meant learned through ISIS, I mean SONiC learned this through ISIS FRR. So the source of this of programming this information into the node is ISIS FRR, but it's actually local to me.
Gotcha. This is your local information. Okay, that makes sense.
Yes.
Okay. Yeah. No, sorry. Yeah.
Okay, no problem. So back to this point of, let's say, for the installation. So when I have to install a seed, then I think the approach that will be right is, and maybe it's still to brainstorm. If someone has other opinion, it's basically when you get a seed with the next hop that does not yet exist, then you have to say you add it into kind of queue or waiting list inside the orchestration agent until you get a notification from the next hop that this seed is become available and you program it. And I think that's the same approach they do for programming the routes in SONiC, like regular IP routes. Correct, Carmine?
Yeah, correct. It's correct, yes.
In my opinion, option one is not a great idea there. Any type of scale, you're going to be quickly wasting a lot of CPU, even if you have a generous retry interval.
Absolutely agree with Donald. It's more of, it's like it's a DDoS attack vector.
Yeah, so just set up a system that lets you know when a next hop comes in, and you can match against it or not.
So you mean option two, Donald?
Yeah, I don't think there's any option one is a no go from my perspective. You're gonna quickly be in a scale situation that just you're gonna if you write option one 2 years from now, someone's gonna go, oh, that was dumb, and then redo it in option two. Yeah. So let's not waste time.
Okay. Yeah, indeed. I mean, we added all options on the table just to, how to say, as a matter of completeness. But I think I agree with you that this one, keep trying forever. It doesn't really scale.
So what's the orchestration agent? What's that? Can you talk about that a bit?
Okay, so I give a quick hint on this, and I let Venkat and Carmen give more. So basically, this is when you install something from FRR into the application DB, there is one agent.
Mm-hmm.
There is one agent that's listening for.
You
have
Eddie, can you mute yourself?
Eddie?
Oh, sorry.
Okay. So basically, you have different tables in the application DB, and for each one of these tables, you have an agent, an orchestration agent that listens to the updates that's coming in this table and program this into the ASIC. So, for example, when you install a new route, there is a route table, and there is an agent waiting there for any new route to come and take this and install it into the ASIC DB, maybe cross-checking with the other tables in the app DB. So from, let's say, putting it in the context of SRv6, so you create an SRv6 SID in FRR, and once you install the SID into a table in the app DB table in SONiC, there is a table called my SID. And
I was just to cut to the chase. I was really asking where the SID came from.
Where does the SID come from? Yeah. In this case, it should come from FRR. So when you create the SID in FRR, the FPM syncd will the FPM module will send it to SONiC through the FPM syncd.
What's the point of sending the SID down before I have a next hop from an FRR perspective?
It's a good point. Then it gets me back to the next slide, because I have this conversation this week with Carmen, is that who takes the control of this? If FRR is the one going to program this, it will never send me a SID without next hop. That does not have a next hop.
So it's a weird situation, right? When you configure a JC SID as part of your IGP adjacency. So it's there and next hop should be available. If your next hop is not available, your adjacency is down, you're not advertising the SID. Right?
Yes, but I think the question here is that should we have this case actually inside SONiC where there is a SID and the next hop of the SID is not there?
Again, it's related to your IGP adjacency. If IGP adjacency is down, you are not advertising the adjacency SID. That's the normal behavior. So practically, you should always have next hop in order to advertise the adjacency SID to your neighbors.
Well, this SID is kind of similar to the static route approach. You have to have it resolved, then you can publish it out. Right?
Yeah, that's what I'm trying to say. Your adjacency has to be up for you to advertise, meaning you have all the IP semantics configured and they're correct.
Yeah, otherwise you could potentially black hole in the traffic, right? Because you publish it to draw the traffic in, but you cannot really handle it locally.
Ahmad, tell me one thing here. This L3 adjacency, it's an end node action, right? So the end node, to reach that next hop, you may or may not have the IGP setup, right? You can very well have some kind of a static route or whatever from that end node to the next hop, right? Or what is the exact behavior we are expecting?
Yeah, so I was trying to understand adjacency seed is not meant for end node actions in general. It's an action,
okay.
I mean, if you compare it to cross-connect, you send traffic without looking it up. In this action, you do L3 lookup before sending. It's very similar to what we do in VPNs, right? In L3 VPN.
Yes.
So how did we come with adjacency seed here in general? I also went through ITF documents. I cannot find any relevant references for that.
Well, I mean, it's already in the network programming RSC, Jeff. So basically, you can have this NDX with associated to a list of layer 3 adjacencies.
Sure, but this is not an adjacency seed then. It's an end behavior, which is completely different animal.
Yeah, it's end behavior with how to say bound to an adjacencies to one adjacency.
No. Adjacency seed points to your IGP adjacency, your IGP that you are using to distribute seeds. If it's L3 interface that needs to be looked up before sending traffic, it's not an adjacency seed anymore.
It's an end behavior.
Yeah, exactly.
Mm-hmm.
So I'm really confused with what you're trying to do here.
So basically, the endpoint for the SRv6, like the SRv6, operations are done once that action L3 adjacency is there, and we need to forward, after removing all the SRv6 related headers, you need to forward your traffic to that particular adjacency next hop that user configured.
No, in this case, you don't have to decapsulate. So basically, when you receive the packet, you do lookup. Yeah. So basically, the packet, the destination address equal my seed. You actually after you do the you have to say you do the lookup to match that it's my seed. You forward through this layer 3 adjacency.
So you will decapsulate all the SRv6 related stuff from the packet. So it will be like a regular L3 packet.
No. It will be forwarded with the SRv6 encapsulation. You don't remove the SRv6 encapsulation.
Okay, got it. So which means like the L3, the next hop should have been resolved before you program this MySeed.
Right? Yes, and it's basically, if you wish, it's like overriding the routing. So you receive the seed, but you don't forward through LPM, but you forward through. I mean, if you forward through this specific adjacency, which at the end bound to you to an interface.
Okay. So, but there is a MySeed static configuration from config.db as well, right? So we don't support that. I mean, if you have such scenario, then there's no IGP or all those things in place. So you need to, create the next hub, when you have the L3 adjacency in the config.db, correct?
Yes, but here again, Venkat, is the logic or the question that we want to ask is that when you get down up to the orchestration agent, what do you assume? You assume that what is the assumption is that the next hop must be there in advance. So if I don't get there,
no, Ahmad, I don't think that's an assumption. There are dependencies are being sorted out in the Arc agent today. So you are basically going to wait until your dependencies are met, and then you are going to program the ACDB. So I think that's all fine. I think option 2 is good. I don't think we are debating for option 2. So option 2 is good. So there are possibilities that you could maybe in this case the expectation is because the ISIS is in the play, you could have programmed the next hop earlier before you get the SID, but there are cases, maybe static MySID programming cases, you may not have the next hop. Maybe I don't think we are handling that case, but I'm not sure whether in your testing have you ever encountered this case where the next hop is not present when you get the SID with the L3 adjustment.
But by the way, option 2 is basically we get it because it's the same way you do the static routing now in the orchestration agent.
Correct.
Yes.
Yeah.
Okay. So do we all agree that option 2 is the right one?
Well, I guess it's still the question in my mind is how are we getting a SID without a next hop?
Yeah.
That was the question we asked earlier that I never heard an answer for.
So
I think the agreement that option 1 is an unacceptable option. That's the agreement.
Which one? Option 1?
Yeah.
Okay. Let's cross option 1. And but the question I get your question, Donald, but so to be honest, I
would say that just from experience here at Cisco, the reason that might come up is is it a static and explicit allocation, right? A fixed allocation. So if that is able to make it down without without any control plane learning this information and tracking the next hop and adjacency, that's a case where potentially you learn this SID before you learn the next hop.
Yeah, but we control that
curiosity,
with FR, right?
Yeah, and sorry, just for my background, when we talk about next hop here, is this just the IP address of the next hop, or does this object also include the L2 information, like the MAC?
So typically FR doesn't. Typically FR does not install a MAC address. You install you install this IP address and this interface.
Right. Okay. Yeah. So that's something that even could be auto-generated if needed, right?
The MAC, yeah. Typically, that's assumed to be handled by waving of hands, the lower level below FR.
Correct. Okay.
Then should this one be basically this dependency resolution should be done in FR? Basically, eventually you need to publishing this MySID to the outside also. So if you cannot really resolving it, then that could potentially, like you publishing it, then that's only the traffic, right? So what option 2 will be moving up to the FR to do the dependency resolution. It's like a static route situation.
But there is another case, Eddie, I think Venkat has mentioned, is basically when you configure this directly without FRR.
It doesn't change the fact that FR doesn't have to hand it down until it resolves it. We can make a decision a priori that FR is going to handle that in this way. And that's what we're trying to do. I'm trying to get the resolution on here or understanding here.
You mean like there's another case that like FR is not there, but then whoever replaces FR should do the same logic, right?
No, I'm not talking about that at all. I don't care about that situation because then FR is not involved, so I don't care.
My question to the more like for the Ahmed, like say for that particular without FR situation, then whoever replaces FR should have a similar idea. Basically, I try to understand why we want to move in the option 2 logic in the OC agent. Why not just let the route, whoever resolving the route, to treat it as the same as a static route situation?
Well, I mean, the reason we went this because it's the way they do it for other things in SONiC right now. So when you do static route, it's the same way. So option 2, we basically get this option 2 from the way SONiC handle it right now. The easiest one, and for I would say, or maybe the where you can control it better is basically an FRR. Is basically to resolve this. But then if you do it differently for the route, why in SRv6 you should keep it in FRR?
But the static route is done in the FRR, right?
Eddie, Donald, we are emulating per VRF label behavior in L3 VPN, right? So you receive a packet and then you look it up. What would be the behavior for L3 VPN within PLS and per VRF label? I think we should follow exactly the same logic here.
But this is not VRF label, Jeff.
No, it's not VRF label. You look up L3 in the packet, right, to figure out where to send the traffic.
Yes.
So when we do it within PLS and L3 VPN, what's the
no? Here you don't do lookup because you have already a given next hop. You override the next hop that you will get with the lookup. It's basically this is to emulate the adjacency.
What if you have more? Okay, wait a moment.
Yeah, I think this, in order to program this next hop, right, the ARP or neighbor should be resolved. So you need to get the ARP resolution, all those things should happen. So that is happening in the ARC agent today. So that is not really FRR's job, right? FRR says, yeah, next hop is there, but whether the associated MAC and all those things resolved or is something should be done at the lower layer, basically. So like what we do for the route. Yeah.
Yeah, but say, for example, for the static route situation,
yes,
you will create the incomplete NH.
Yes.
So from the FR point of view, you still complete. You have the NH created. Then it will be resolved. So why we keep the same logic? So from FR point of view, always. So then in that situation, NH should always be there. Then the MyState will point into that NH. You don't really care if it's resolved or not resolved. It could be incomplete because the FR doesn't care for the ARP resolution.
Yeah, correct.
But the dependency should be resolved in the FR.
That sounds right. Yeah.
Yeah.
Which I think that this change, the second option or the second check is basically it's not that if the next hop does not exist, but if the next hop exists but not ready, because I mean the ARP maybe is not resolved or something like this, but it should be always there.
Exactly, Ahmed. I think that's correct. Maybe we can clarify that here. The next hop, I believe from Zebra to FBM SIGD, you would have not got that MySeed itself with the next hop is not present. So
yes. So I think the second option, the second if statement, Carmen, is basically is not the next hop does not exist, but it's more if not ready, because this you can wait until the ARP is resolved or something like this, but the next hop has to be there, and this is something that will be handled by FRR. When you have a SID, you will have a next hop anyway.
If the ARP is not resolved, it will be the same as the current one, right? Once it is resolved, it will change from incomplete to complete.
Yes. Can you edit this slide, Carmen, just to change it from next hop does not exist to if next hop not complete?
Yeah.
Or
okay.
And cross option 1, we do option 2 as discussed. Okay, so
Tom? Sorry?
yes, if you can put option 2 in green, because that's the one that we agreed.
Yes.
Okay. So just to recap here, if we get the seed and the next hop is complete, we install. If the next hop is not complete, we actually wait. But if the next hop does not exist, that means we fail, because it must be there. If for any reason the next hop is not there, we should fail it. We should not try to install.
Can we define semantics of non-complete? Right, it's a transitory semantic, right? It needs to be clearly defined.
Complete, maybe if you can put between brackets or something like this, Carmen, that okay, ARB not resolved, or. And Venkat, it's a question here. When you have a next hop with, let's say, do you have a state machine for the next hop that complete, incomplete, or something like that we can check from the orchestration agent?
Yeah, so basically from the neighbor perspective, that state machine is in the kernel basically. So when you send the packet, it will be transitioning from incomplete to reachable, right? So that's all for the neighbor. Once you got the reply for the ARP request, you are moving it to reachable. That's when you have all the information complete. Then you will add the neighbor to the ASIC DB. So as part of that, you will also create the next hub and all those things. Then the dependent be it route or other like SRv6 L3 adjacency cases will be programmed.
Okay.
Yeah.
Okay. Again, out of curiosity, so it's not the responsibility of any of the components we're talking about to trigger an ND request to try and resolve this, right? As soon as the next hop exists, somebody else takes care of maybe doing gratuitous ARP requests, or
that's correct.
Or do you need to install something in traffic to try and hit it before that gets resolved?
No, basically there is from ARC agent, if the next stop is not there, I think there's a message being published, and the neighbor manager handles that event, and then it sends the ARP request from the kernel.
Okay.
So practically when we say incomplete, it's an ARC agent semantics.
Yes, it's everything here. I think, Jeff, we are talking inside ARC agent.
Okay.
Yeah.
It's basically the component that we are extending with this pull request. Okay. So the second case is delete. I think it's no brainer. When you get to delete the seed, you delete and decrease the ref count. Carmen, can you add under this delete statement just a new bullet where, and I think by the discussion we have today, this case is resolved. It's basically when you have a seed, and basically the next hop of this seed is deleted. So I would believe that the one who deletes the next hop should delete the seed as well.
I have another slide on this.
No, just add it to this. The other slide has too many details that we don't need.
Okay. So which is the case? We have a seed installed, and we
installed, yes.
The next hop is removed.
Yes. So in this case, I think it should not be the orchestration agent to do this, because the one who is removing the next hop should remove the seed as well.
Yeah, that's correct. I think for better performance today, we don't wait for the next stop. I believe I think we don't wait for reference count to become 0 to from FRR, because all the associations are removed. Then only we can remove the next stop. But for interface down on all those cases, I believe we go ahead and delete the next stop and remove all the associations immediately.
But how do you notify the let's say how FRR learns that the next hop is removed? to remove all of the object pointing to it.
Correct. So basically, the application DB entry will still be there, but you would have removed that information from the hardware. The ASIC DB would have cleared. But from FRR point of view, if all the things are removed, basically you will remove the entry from the application DB.
And FRR learned through the kernel.
FRR learns through the kernel. That's correct. Yes.
Okay.
But the FR only handle the interface down or the IP is removed from the interface. Then the next hop will be removed, right? Because the ARP resolution will be done in the off agent. So this next hop remove can only happen either like interface down or the IP is removed from the interface, right? So then in that situation, it's more like static route cannot be resolved in the FR.
Yeah.
So, but the third use case here, Venkat, is actually out of the scope of the orchestration agent. This one is not handled by the orchestration agent right now.
Yeah, I mean, that's what we need to see. Like today, to get better performance, we because the next hub associated interface is being removed, is down. So naturally, all the static routes and all those dynamic routes are going to be removed. FRR is in the process of removing each and every associated information, but before that we will remove it in the ARC agent, and then we will be getting that route delete events one by one from FRR, and application DB will be removed, and then the ARC agent also will clean up. But the ASIC DB would have been done early.
But for the ORC agent, when you delete the next hop from the ASIC DB, you delete also the route, or you wait until FRR deleted?
I think we will delete the because there is a dependency, right? You cannot have the route without the next hop. So
yes, that's what I'm asking for.
I think all the dependent information will also be removed when you delete the next hop. Yeah.
Okay, so which means here that if I have a SID installed and the next hop is removed, then I should learn it in my orchestration agent and delete it from the ASIC DB until FRR deleted from the app DB as well.
Correct. That's what we need to see, Ahmad. Like the current behavior for the routes, it's like that. But when the moment you associate SID to the next hop, whether we are going to disturb that behavior with SID, or you are going to honor that behavior, whatever is already there. As part of removing the route, you are going to remove the SID information also from the ARC agent before you get that event from the FRR.
But it means this means that for some time, FRR will be still advertising something that you don't have in the ASIC DB.
That's correct. Yes.
Okay.
Just look at that and see if that makes sense. The current behavior. Do you see any issue? If at all you see any issue, then we need to see how we can fix it.
Okay.
But that would become interesting. Like say, let's assume you already defined the adjacent state, but adjacent state is not cannot be resolved. How do you let the remote guy know that they don't use this adjacent state?
I mean, it depends. It's if it's static explicit, there is no withdrawal, right? This would be controller knows that it exists. If it's IFS, then they must learn they lose their adjacency to their neighbor as well, right?
But we don't know that adjacency is resolved or not resolved. We only know the interface up. So FR doesn't aware of it. So he will publish this adjacency state out anyway.
But that's back to the same question, how FRR will learn about this again. I think Venkat said they learn it from the kernel, no? They know about this from the kernel, and FRR will remove the seed and not advertise it anymore. I don't know. I don't know much about FRR.
No, FRR next hop is from the protocol itself, right? The next hop.
Mm-hmm.
So for kernel, you'll all knows is okay whether the the given interface is down, then okay the dependent information will be removed by FRR. But other than that, the next hop has to come from the protocol itself.
Yeah, which means FRR from FRR.
Yeah. So when you have the ISIS neighbors, right, you have some IP address, right? I believe that the same IP addresses is what you are going to use as part of the L3 adjacency also, correct?
Yes, it's the same IP address.
Yeah. So then I believe that it would have been programmed as a next hop and all those things by the time you program the seed.
Okay.
So basically, even for sending the the protocol packets, this ARP should have been resolved, and then only you could have the other guy will receive the packet. So.
I think that probably is similar to the static route pointing to an incomplete adjacency cannot be resolved at all. But the moment ISIS can still publishing that static route out. So that more considered as a configuration like a mistake because nothing we can do in that situation. Jeff, I saw you put some comments in the chat.
Yeah, so this is how you would configure it in kernel, the DX4 and DX6 inductions.
Yes.
So, but as you could see, based on the encoding, it could mean an adjacency to send traffic out without particular lookup, or if it's set to double com, you actually need to do local lookup, at least in the 6 case, right? So both need to be supported.
I know, but I think I see the point here of the kernel configuration. But this is a special case when you have the you don't set the next hop at all. You're referring to the point where if the parameter is set to colon.
Yeah, correct.
Double colon.
Yeah.
Yes. Okay.
So with the colon, this becomes like a DT6 or T, or I guess into the same verf though. Okay.
Yes.
Yeah, so if you compare it to LGVP, and it's per VRF and per next hop level location.
Mm-hmm.
But this next hop doesn't mean there must be the local like ARP adjacency, right? It could be the
it needs
recursive
to be
next
fully
hop.
resolved. Yeah.
I think we haven't talked about if this next hop is a recursive situation, then what do we do? Right? Because this right now we assume the next hop must have up resolved, which means this next hop is adjacency prefixed. But what happens if the next hop is recursive? From the draft, it seems it's reasonable, right? He was doing as an IPv4 lookups. Then, which means the next hop resolution should be done. Also, could you potentially over the normal forwarding next hop? So FR need to resolving it. It's more like a recursive static route situation.
Yeah, but we said we are going to use ArcAgent semantics, right? So it's up to ArcAgents to make sure route is fully resolved and usable.
ArcAgent cannot do that, right?
Yeah,
route
he
resolution
can signal it.
My point is, should this one be done in the FR instead of the ArcAgent, right? Because if it's a recursive situation, you have to let Zebra to resolving it to track the resolution. Because the RIB is the place for all the next hop resolution, right? In here, we only say, hey, if it's an incomplete situation, but that's a very corner case. We also have a case like the next hop is a recursive situation.
But again, Eddie, when it is a recursive situation, who should do the recursion here? Should it be FRR
it should be FR.
Or yes?
It should be FR, right? Because it doesn't have because you only want one guy to be the RIB job, right? You don't want both guys doing the RIB job.
Mm.
So I would say like probably we need to have a third bullet. The next hop is recursive. Then FR need to resolving it.
Yes. Okay. Carmen, can you add this palette? If the next hop is recursive, this should be handled by FRR, not in the orchestration agent.
Yes.
You can put it in the third bullet in the install set.
Yes. Add this as a sub-bullet of the install set.
The first one, no? Yes.
Yes.
Well, I just want to make sure we're talking about the right thing. So here in the example in the chat, we're talking about NDX, right? That's an L3 VPN per CE type allocation, right? But I thought we were talking about adjacency SIDs, which is an NX.
But these cover both, let's say, Michael, it's basically this layer 3 adjacency parameters in SONiC can be associated with an end.dx6, dx4, and x as well, without decapsulation.
Right, but I okay. Okay, I need to think about that a little bit. Okay.
Yeah, we are 5 minutes past the time. Any last comments? So, Ahmed, what's your next step for this proposal? You will circle back to the SONiC community?
Yes, we already did the update to the SONiC community. Maybe we will need to ask if we how to say to present this conclusion again to the SONiC community, or we just go ahead and update the pull request and we will add this comment on the PR, because I'm not sure if we will manage to get another slot because they are running out of how to say, of presentation slots in the main community. So for sure, we're going to add all of these how to say, points that we get here on the high level design, and we will implement or update the code to implement this.
Good.
Venkat, since you were there in the community as well, do you think there is something that we should do again in the community, or we can update the code with this?
I believe we already discussed this L3 adjacency in the community meeting, right?
Yes, 2 weeks ago.
I think we are good. I mean, generally, I think the guideline was to first discuss in the work group and then the community meeting. But in this case, we did reverse. So I think we are good. As long as we, address all the comments, I think we can take all those things offline. We don't need to discuss it.
Okay. Sounds good.
Okay, good. Thanks.
Okay.
Okay.
Many thanks, Eddie, for hosting us today, and thanks for all of the people who joined the call, and many thanks for all of the comments.
Okay, thanks, Ahmed. That's late for you guys. Yeah, thank you.
Thanks, everyone.
Thank you. Bye.